Hi guys, welcome back to another video. This is a follow-up to the previous integration by parts video. The first video was a tutorial on the basics of how integration by parts work, but in this video we're specifically going to be looking at integral of inverse tan x. When you get a sum like this and you feel that you cannot really solve it using substitution, you can look to integration by parts. So how do you go about solving that? Well, this equation can be written as the 1 into inverse tan x dx. So now we have two different terms, and one is an algebraic function and inverse of tan x is an inverse trigonometric function. We have these two terms, and again refer to my previous video if you're getting lost, but we can see that inverse trigonometric function comes before algebraic functions. So we can take u as tan inverse of x and dv as 1. So now we have to find out du. So du over dx would be 1 over 1 plus x squared. And if you guys don't know how this works, I've written down the derivatives here. This is found in the IB Math HL formula booklet, but I strongly recommend that you guys learn all this by heart. If you learn the derivatives, you also know that the integral is just the other way around. The derivative of inverse of tan x is 1 over 1 plus x squared, and now if we integrate both sides, we get v is equal to x. Over here we can simplify du over dx as dx over 1 plus x squared. Now using this formula here, we can write it in the form where u is inverse of tan x into v, which is x minus integral of v, and if you add du, that would be dx over 1 plus x squared. So now that we have this, we can simplify this further. So that would be x over 1 plus x squared dx. And here I'm going to be using a shortcut to solve this integral in one step. And if you don't know how to do this, I made a separate video about it, and it'll appear in the cards about now, and it'll appear in the description below. So please go check it out. It'll actually help you save a lot of time in your IB Math HL when it comes to calculus, and I strongly recommend that everyone learns it. I'm going to be applying the shortcut. So as soon as I see the denominator, I can see that the derivative of the denominator is 2x. So the numerator and the denominator are in the same form. So basically, we can see that the derivative of the denominator is 2x. And the only difference between this derivative and the numerator is, well, the constant 2. But constants barely matter in integration, and we can easily manipulate that. So I can write this as into 2x over 1 plus x squared dx. Let me just clear that out. And now, as you can see, that the 1 over 2 and the 2 cancel out, but at the same time, now the numerator is a direct derivative of the denominator. So this can be written as minus 1 over 2 ln modulus of 1 plus x squared plus c. So this is the solution. So if you guys were lost in any or have any doubt when solving integration by parts, I urge you to check out the first video, which I'll leave in the description and in the cards. The shortcut over here I've mentioned in a different video. Lastly, I've made one more video regarding integration by parts where I solved the sum e power x into sine x. This is a standard question which IB likes to ask, and it's more complex than it seems. So I've made a separate video about this, and I'll leave a link in the cards right now and in the description, so go check that out as well. And that video will help you further your understanding in integration by parts. Thank you for watching this video, and I hope to see you in another video.